whiteboard. Okay, so besides thinking about this in terms of our SOHCAHTOA, our opposite and adjacent and hypotenuse, I also am going to ask that you start to try to memorize this in relation to the X and the Y and the R. And you're kind of going to see two different applications as to how or why we're going to do that in terms of types of problems you're going to be asked to do here. Okay, so all right, we know sine is opposite over hypotenuse, right? I'm just going to put those abbreviations. But if we are thinking about that in terms of x's and y's and r's, I need you to notice that for sine, if we're going to do opposite over hypotenuse, that is equivalent to y over r. So you're going to need to get that memorized. Sine ratio is going to be y over r. If you notice, for the cosine ratio, when we normally do adjacent over hypotenuse, right, that corresponds to x over r. And for tangent, we know we think of that as the ratio of opposite over adjacent, right? So opposite over adjacent, using x's and y's and r's, that means we have y over x. Okay? All right. So, yes, something new to memorize. So for the sine ratio, we're going to think y over r. For the cosine ratio, we're going to think x over r. And for the tangent ratio, we're going to think y over x. Okay, and like I said, you will see application here in just a second as to why you're learning this and how we're going to use it. I do not have memorized what the ratio is for cosecant. I think about what the sine ratio is, which I know is y over r, and then I just flip it. So for my cosecant, I know it's going to be the flip of whatever my sine is. Right? For my secant, I'm thinking the reciprocal, I'm going to flip what I know my cosine is. So that is the r over x. And for cotangent, I'm going to flip what I know my tangent is because it's a reciprocal. Okay? So you don't need to memorize those per se, but you do need to get those reciprocals memorized so that you know what you're going to flip, if that makes sense. Okay? All right, so here's one application of when you will use these x's and y's and r's. So if we are given quadrantal angles, so it's been a while since we've talked about that term, but quadrantal angles, remember, are the angles that lie right on our x and y axis. So our 0 and 360 are 90 degrees, our 180, and our 270. So what's special about those is if we have to find a trig function for those, we can't draw a triangle. We can't think opposites and hypotenuse and adjacents. We can't create a triangle because it would basically collapse on itself onto the axis, right? And so instead, we need to be able to think about our ratios. John, what's your lucky number? You don't have a lucky number? Oh, Dina, what's your lucky number? 64. Okay. All right. Whatever your lucky number is, if you want to write that number, if you want to use 64 instead, that's totally fine. I'm going to use 64 since that's what she's... So I want to think about going out a distance, a radius of 64 units, right? So I want you to think about the fact that that means at 0 and 360 degrees along that axis, that means we would go out 64, and then we're not going up or down. So we're at 64, 0, right? And then up here, we would be at 0, 64. Over here, we're at negative 64, 0, and then down here, we're at 0, negative 64. Like I said, if you want to use your favorite number or your lucky number instead, that's totally fine. Just be consistent with whatever number you're writing in there, okay? All right, so we want to look at these ratios and write what the answer will be. What I want you to notice is that there are going to be basically 4 answers that you're going to see for all of these, okay? Because what's special about these is that we have these zeros and we have these negatives and that type of thing. So you'll see what types of answers that we get for this, okay? So for our sine of 90 degrees, think about what that means we're going to do. For sine of 90, first it means we need to think about the ratio that we're going to use. So we're going to do y over r. So at 90 degrees, we need to look at what the y value is, which is 64, over r, which we know is 64. So we get 64 over 64, so our answer is just equal to 1. Okay, for the cosine of 180 degrees, what's the ratio for that? Sam, what's the ratio for cosine using x's and y's and r's?
X over r.
Okay, so for cosine, we're going to do x over r. So we're going to look at 180 degrees, that coordinate, and we're looking at the x value, which is what, Sam?
Negative 64.
Okay, over r, which is
64.
64, so we get negative 1. So the cosine of 180 degrees is negative 1. If you're using your favorite number instead there, then you're going to have, like for me, it would be negative 7 over 7. You're still going to get negative 1, right? Whatever number you choose to use rather than 64 if you don't want to use 64. Okay, tangent of 270 degrees. So tangent, Alex, what's the ratio we're going to do first using x's and y's and r's?
Y over x.
Okay, so for tangent, we're going to do y over x. So we're looking at 270 degrees, and y is how much? What's the y value at 270?
Negative 4.
Negative, what did you say? Negative
64.
Negative 64. Are you, if you want to change it, you can, we can. If you want to put a different number. But then what's our radius? Or no, I'm sorry, what's our x? Because we're doing y over x, aren't we?
Yeah.
So negative 64 over 0. And that is undefined. All right. If you need to put a little note, a reminder over here, remember 0 over a number is okay. That means we have 0. A number over 0 is no way. That means we've got something that's undefined. So it might be helpful to have that reminder written somewhere there. Okay. I'm gonna, all right. So looking at the ratios, we're just deciding, is it x over r, x over y, whatever, right? And then we're looking at that particular coordinate, and then we're looking at that ratio. So our answers are 0, undefined, 1, or negative 1 for all of these quadrantal angles, okay? But now we're going to look at examples of another type of way we will use these problems. If you notice on the top of the next page, we're just given a coordinate point. I didn't put any directions there, but the directions will say something to the effect of state the 6 trig ratios for the given point. Okay? So that means we're going to state the sine of theta, the cosine of theta, and the tan of theta, and then its reciprocals. Okay, for this first one, I'm gonna draw the triangle just to kind of help you think and see about what this is all about, but we're not, I don't typically really want you drawing the triangle, right? If we're at the coordinate point negative 9, 12, then we know, think about why I drew that triangle in quadrant 2. We're going left 9 units, we're going up 12 units to get to this point right here at negative 9, 12. And to draw that triangle, remember, you're going to put a point, you're going to draw to the origin, and then you're going to drop your perpendicular to the x-axis and put your little right angle. So from your point, draw to the origin, go back to that point, draw to the x-axis. Okay, so we have that point, negative 9, 12. We need to figure out what our hypotenuse is, or more specifically, thinking x's and y's and r's, what is r? So what is r going to be equal to in this case? Can't be 12, because that's the same. But I think you're on the right track there. So this is a triple. This is a Pythagorean triple, guys.
No.
Okay, yep, everything's getting multiplied by 3. So that's a 3, 4, 5 triangle, and all of the values are getting multiplied by 3. So 5 times 3 gives us 15. So our radius is 15. Okay? So I think you were thinking through that and just weren't realizing you needed to multiply through by that 3 there, Kylie. Good. Okay. So we have a 3, 4, 5. I don't want to use the triangle. I want to think about just these points. So think about the fact this is our x, this is our y, and here's our r. So for sine, we're looking at the ratio for sine is y over r. So Maya, what is the value for y?
12 over 15.
There you go, 12 over 15. Now we do need to reduce that. So let's divide everything through by 3. So we get 4 over 5. And here's the beautiful thing. Once you figured out the sign, you just have to flip this to give the cosecant. Excellent. Good work, Maya. Elena, what about the cosine? What's the ratio for cosine using x's and y's and r's?
X over R.
Okay, and so our x value is?
Negative 9.
Negative 9 over r, which is?
15.
15. We want to simplify that, so we get negative 3 over 5. So negative 5 over 3. That's messy. Okay, Talia, tangent ratio is? Y over x, so what are those two values?
12 over negative 9.
There you go, 12 over negative 9. Let's reduce. So divide by 3, so 4 over negative 3, so negative 3/4. Okay. So yeah, we got to get the x's and y's and r's memorized besides SOHCAHTOA now, right? All right, take a couple of minutes. I just want to refresh your memory on how you're plugging in. Notice what it's saying in these problems down below. I want you to do both sections of 1 through 4. The first section, you are truly just plugging in as it is. That second section there, notice you're finding angle measures. So how do you plug that into your calculator if you are finding angle measures? How are we going to plug in number 1? We're finding an angle measure. Uh-oh. Guys better think about that. You got to remember these on those down below. So that first section, you are truly plugging in just as it looks on those problems. When you are finding angle measures, you've got to remember to do the inverse trig function. So inverse sine, inverse cosine, and whatever. It's the bottom row of on the calculator screen with the trig functions. So John, what'd you get for the first angle? 54.9 degrees, good. And then for number 2, Sam?
18.5.
Okay, 18.52 degrees. Elena, number 3?
12.2648.
Yeah, 12.2648 degrees, if you go out that far. And then on the last one, CJ? 49.09 degrees. There you go. Guys, you've got to remember that inverse trig function for angle measures, right? So you're finding the angle measure, so that's what theta is equal to. So I think it's helpful to write that theta equals, just to kind of help remind you of that. Awesome. We are skipping over to page 27. So we are talking reference angles now. Okay, so I need you to notice how it explains this, and I'm going to show you some visuals of what reference angles look like. Okay, so reference angles are the positive acute angle made by the terminal side of an angle, right? That's where it ends after it's rotated, and the x-axis. Guys, always, always, always the x-axis, never the y-axis. All right, we'll get back to this visual here in just a second. What I want you to notice, though, what I want you to think about is if we have an angle in quadrant 1, right? So we rotate to some particular place. Here's my terminal side. Here's the positive x-axis. So the reference angle ends up being exactly the same as whatever the angle measure is. Okay? In quadrant 2, if we have an angle that rotates and ends in quadrant 2, here's where their reference angle is. Our reference angle is this angle right here. So one way of thinking about it is you're kind of trying to consider how much more would I have to rotate in order to get to 180 degrees. That's the reference angle, okay? In quadrant 3, so look, that next example I've drawn ends in quadrant 3, that's its terminal side. The reference angle is this small angle here, the acute angle between where it ends and the x-axis. So another way of thinking about in that particular quadrant is how much more or how much beyond 180 degrees are we rotating? Okay, and then for this last one, if we have an angle that ends or terminates in quadrant 4, the reference angle is this angle here. It's the distance, think of it as saying how much more would I have to rotate in order to get up to 360 is another way of thinking about that. So that's kind of what this visual here gives us, tells us, and helps us see is if we're given an angle, depending on the quadrant that we are in, that's what we're going to do in order to find our reference angle. Okay, so that's just kind of a quick visual to help you with that. So let's look at some examples real quick, and then I want you to try a few. It says sketch the reference angle, theta prime, and give the measure of what theta prime will be in degrees. So if we have 285 degrees, I want you to think about the fact that we're starting here and we're rotating around to this place. So our reference angle, hey there, good morning. So our reference angle is this amount right here. So we're in quadrant 4, so notice that means we're going to do 360 minus whatever that angle measure is. So 360 minus 285. So we find that the reference angle is 75 degrees. Okay, questions on that? Does that kind of make sense, I hope? Okay, 194 degrees means we're rotating around to about right here. Right, that's about where 194 degrees would be. So we're ending in quadrant 3, so that means we're going to do angle minus 180. So if you think about it, it's this angle right here. This is the reference angle, and it's basically telling us we're rotating 14 degrees more down below on this from the x-axis. Okay. 120 degrees means we're rotating to about right here. So our reference angle, or theta prime in this case, this is what they're asking us to label it, is this angle here. I'm not actually labeling it, but we're doing the math for it. So we're ending in quadrant 2, so if you notice, we're going to do 180 minus the angle. So we find that that's a 60-degree reference angle. Okay, now on this last one, we've got an angle measure that's well above 360. So we need to think coterminal angles to begin with. In other words, we need to subtract 360 and figure out where this angle is somewhere between 0 and 360. So that gives us 330 degrees. So that helps us think about how we're going to rotate. So 690 means we are rotating around one full time and then another 330 degrees. So we're about right there. Okay. So to get our reference angle, we're looking at this amount, this distance right here, because remember it's the acute angle between the terminal side and the x-axis. So we needed to use that coterminal angle to get the 330, so then now we can do 360 minus 330, or 30 degrees. Okay. All right, you're going to kind of see an application of this here in just a second as well. So on this next page, you notice this kind of talks you through an example. If you notice, it says draw the angle. That's what we did first. Where is the terminal side? So decide on the quadrant and then determine the measure of the acute angle that the terminal side forms with the x-axis. So this is just kind of a step-by-step of what we just did, if you want to kind of think through that process. But try these for yourself. These right here. So grab a calculator, just try figuring out what the reference angles are for those. We'll go over those in a second. That's in quadrant 1, so it's whatever that angle measure is. So 83 degrees for that first one. 213 degrees goes into which quadrant? Quadrant 3, good. And so you're doing 213 minus 180. So what do we get? 33 degrees. Yes, thanks, CJ. All right, 290 degrees. Elena, what'd you get for that one? 70 degrees, good. And then that 134 degrees, John?
So I was confused. You do that, you minus that by 180, right?
Well, other way, 180 minus the 134,
Okay.
right?
Yeah.
So what'd you get?
64? 66?
You're switching it. Are you going? Should be 46 degrees. If you do, because 134 is going to end in quadrant 2. So if you look at the little visual here, in quadrant 2, you're going to do 180 minus whatever that angle is. So 180 minus 134. Okay? All right, for the 200 degrees, Talia?
20 degrees.
Yep, 20 degrees, good. Essentially saying 20 more degrees from that x-axis on the left-hand side, right? And from 300, for 300 degrees, we're doing 360 minus 60, so we, minus the 300, so we get 60 degrees. Okay? All right, this next little bit, I'm gonna show you, it's kind of a visual, so I've kind of tried to color code things here. So one of the main reasons why you are learning about reference angles is that we want to be able to talk about or think about, there's a connection and a relationship between all of the 30-degree reference angles that we have in each of the 4 quadrants. So what we know about a 30-degree reference angle in quadrant 1 is true for quadrant 2 and 3 and 4 as well. So we want to think about, and this is another thing to start getting memorized, what are our 30-degree reference angles? What are the 45-degree reference angles? What are the 60-degree reference angles in each of the quadrants? Okay? So in quadrant 1, like it should make sense to you that in quadrant 1, our angle, it's just going to be the angle, a 30, a 45, and a 60, right? But let's think about in the other quadrants how we would figure out what the reference angles are. If we're in quadrant 2, we want to figure out what the 30-degree reference angle is. So we're kind of going backwards. We're saying we're here at 180. If we go back 30 degrees from there, then we're at 150. If we're at 180 and we go back 45 degrees, we're at 135. And if we're at 180 and we go back 60 degrees, then we're at 120. So those are our 30, 45, and 60 degree reference angles in quadrant 2, okay? All right, in quadrant 3, I've color-coded this blue. Think about it. We want to take 180 and we want to add 30. 180 plus 45, 180 plus 60 to figure out what those reference angles are. So 180 plus 30 is 210. 180 plus 45 gives us 225. And 180 plus 60 gives us 240. And then the last set for quadrant 4, if we're at 360 and we subtract 30, we're going to be at 330. If we're at 360 and we subtract 45, we're at 315. And 360 minus 60, we get 300 degrees. Okay? So that's to kind of help you think about that. But now what's going to be important and what's going to be special that you guys are going to need to be thinking about, like I said, really the application is we need to be able to look at those. If I start talking about an angle that's 210 degrees, you need to think about what you know about a 30-degree angle, because it's going to be true for that 210-degree angle also. Because 210, the reference angle for 210 is 30 degrees. So you need to memorize these 30-degree reference angles, these 45-degree reference angles, and these 60-degree reference angles. And if you've done any work with unit circle, you know where we're headed with this. And some of you I know are familiar with that. Okay?